So I somewhat got ahead of myself last time. We're not ready to talk about detectors yet. There's one more piece that concerns the column area that we need to discuss. And this is where the column is housed. So the column is placed into a part of the GC called the oven. Okay? So I've used this word a time or two already in the previous lecture videos, but this is the GC unit, and the column is on the inside of this system, and it goes round and around and around and around and around, and then up the other end. So this is the detector of the instrument that maybe sits up here finally to see the stuff, and here is the injector port of the instrument where I would inject my sample. So this whole area of the GC inside of the GC system itself is called the oven. Okay, and the oven has to be heated up, and that's the triangle that I begin to draw. And that oven really makes your compounds separate. So the oven is the temperature controller, and that is what regulates the temperature on the column. And that column is what gets your samples. Okay? So if I had to take a look at an actual GC picture with the oven, typically on the very front of the GC system itself is a door. And this door will open up. And this door is insulated, as you can see here to the left. And there's my carrier gas tank in the back on the left. And inside is the capillary column itself. And you can see that wound up on its cage and installed inside of the machine. So this oven door opens up, and this is where I install the column, and this is where the column is housed and kept. And up here at the top is the injector, and my sample goes in, and then it probably goes out the top as well, and that's where my detector is located. So this is the oven, and just like the oven in your kitchen, this heats up to different degrees. Okay, and you set what those temperatures should be. So here's another picture of the inside of a GC system, and this is the oven area, and my column has been installed on the inside of that. And this column will heat up or cool down depending on what my oven is doing from beginning to end as far as the method goes. Okay, so a couple of things that you need to take away. Uh, First and foremost is that it's very important to set the temperature on the oven. And the temperature on the oven, initial temperature and final temperature, sometimes has to be set, but these are always in degrees Celsius. Okay, it's not Fahrenheit and it's not Kelvin. It's degrees Celsius for the most part. These ovens traditionally can go upwards to about 350 degrees. I'm going to say anything over 350 is very rare. However, there are columns, and you saw one in the previous video, that can go up higher than 350. But 350 is typically pretty standard, pretty kind of run-of-the-mill type of column and type of GC instrument that's sold on a traditional day-to-day basis. Anything higher than 350 is bad. It's bad for your column. It could be bad for your samples. It could be bad for the oven. But this is traditionally the cutoff. This is the max, is what we would call it. There's two different types of ways that you can run your oven. Okay, the first one's called isothermal, and iso means same, and thermal means kind of in a way temperature. So an isothermal analysis would be I start my analysis at maybe 180 degrees, and I make no changes to that throughout the analysis run, and I end at 180 degrees. Isothermal runs are very good for compounds that maybe are very simple as far as mixtures go. Maybe there's not a lot of things involved in the sample itself. And maybe those things that are present have very large boiling point differences. One boils off at a low temp and one boils off at a much higher temperature. Well, isothermal would be a very good method to use to run that sample with. It's very simple. There's not a lot of work that your GC instrument has to do in order to make it happen. And it starts at one temperature, it ends at one temperature. This is like baking your cake at home. You put it in at 350, you keep it at 350 the entire time until the cake is done, right? Okay, well, there's another type of gradient or temperature setting, and this is called a thermal gradient. Some people use temperature gradient instead of thermal gradient. I don't really care what you use, but whenever you see the word gradient, that typically means that something is changing. And thermal means temperature. So the temperature changes in this type of analysis. And maybe what happens here is that you start the instrument at 180 degrees, however, you end the instrument at 300 degrees. This is traditionally the most common type of method that we have in a laboratory. It's the thermal gradient. And the reason is because the samples that we analyze are very often complicated. And if we have complicated samples, then an isothermal is not going to work for us. We need to play around with the temperature settings, and we need to go in and tell the machine to heat up and cool down accordingly so that we can get a really good separation of the components that are in my sample. The temperature ramp is also a setting that you traditionally have to use. And I put rate, this needs to be ramp. The temperature ramp will give me an idea of how fast, okay? And, I could go in here and say, I want you to start at 180, and I want you to end at 300, but I want that process to be maybe a little slow. So I can put 5 degrees per minute. So 180 it starts, 1 minute later it's at 185, 1 minute after that it's at 190, 1 minute after that it's at 195, 1 minute after that one it's at 200. So you get the picture, right? Or I can tell it maybe to heat it up a little bit faster. I don't need to wait that much time. I need you to heat up, but I want you to heat up a little quicker. So 180 to start with, 1 minute later it goes to 190, 1 minute later it goes to 200, 1 minute later it goes to 210, 1 minute later it goes to 220. So you can see how fast maybe that one heats up compared to the previous one. These numbers can be whatever setting you need them to be. They can be as low, 1 degree a minute, or as fast, maybe 50 degrees a minute, depending on your analysis and the samples that you need to run. So that is what we call the temperature ramp. So 2 different types of methods that can be out there. Isothermal starts at 1 temp, the temp never changes, and it ends at the same temperature. And then we have thermal gradient, which means it starts at 1 temperature and it slowly or quickly heats up to a completely different temperature at the very end of the analysis run. Okay? You, keep in mind, don't have to always heat. So for instance, I could say I want you to start at 180 and go to 300, and then I want you to go back down to 250. That's not very common though. Typically, the hotter you get, well, the more things come out in the order that they're supposed to come out in. And very rarely do you go lower at the very end. But that is a possibility that you can do. But traditionally it's always lower in the beginning and higher at the very end. Okay, so that's called the oven. That's the purpose of the oven, and it controls the temperature that your column is at throughout the entire analysis run. Okay, so that's the next piece that we should have talked about instead of going straight to the detector. But now we can kind of make our way a little bit closer to those detectors. Okay. GC oven, isocratic or isothermal. That's another name that it can be used for, isocratic instead of isothermal. And here they just say gradient. They don't really say thermal gradient or temperature gradient. It's kind of understood anyway. To give you an example of the power of the gradients, here's an example of a sample that was injected using an isothermal method. So this was a start at one temp, end at the same temperature. There's no changes made. And you see a couple of different peaks that have separated out here to the right. But it looks like there's a cluster of different ones that are happening right in here on top of each other. And we need to separate those a little bit more so we can see those samples a little bit better. So isothermal will not work for this particular type of sample. So we use a gradient instead. And we tell the oven to start at one temp and maybe slowly heat up to another temperature and see if our analysis is better. And sure enough, it is. So this represents a thermal gradient. If you look, it starts off at one temperature and it kind of hangs out for a little bit. And then it begins to heat up hotter and hotter and hotter and hotter and hotter until it gets to a certain point. And then it kind of holds out at that temperature a little bit longer. And then this dotted line means that it cools back down. And it's cooling back down to the initial temperature that you started with. So that way it can get ready for your next sample that you need analyzed. All right, so that's the temperature ramp that we would see on the screen. And if you look at what happens, all of these components now begin to separate a little bit better from each other. So compare these peaks, very distinct peaks, very sharp peaks. They are separated from each other, even these beginning ones, versus something that looks like this, right? There's a lot of stuff that's happening on the front end of this chromatogram that really shouldn't be there. That is a very bad sign that your separation method is not working out for you. So change the temperature, and when you change the temperature, these things become a little more separated and you can see them a little bit better. Okay? So some questions that you have to ask or go in and set. What is my starting temperature? What is my ending temperature? And how fast should it heat up? And that's what we call the heating rate. Okay? So that's software settings that you have to make and ensure that they are present before you go any further. So now I think that we're ready to finally talk about a detector and what does the detector do and how does it do its job. We won't really talk about all of the different types of detectors out there because there's tons, but we'll at least do a general overview of some of the most common ones, especially the ones that you'll be using.